This is the video that goes with section 1.3, which was solving equations with variables on both sides. This is what we did on day one. So on day one, we did an exploration in groups and partners where you used perimeter and area of a figure to write equations that had variables on both sides, and then we solved them. So if you weren't doing well on the exploration, or you still had some questions about it, if you'll watch this portion of the video, it should help clear it up. So the instructions said that each figure has the unusual property that the value of its perimeter in feet, so remember perimeter is the distance around the figure here, is equal to the value of its area in square feet. Okay, so we use that information to write equations for the figure. So notice this is a composite figure. That means that it's made up of two shapes. This is made up of a rectangle and also a triangle. So I'm going to use that information whenever I'm writing my area. As far as perimeter, I'm just going to add up the outside of this figure, the measurements. So here I have a 5 plus 5 plus 4 plus 4 plus x. Well, 5 plus 5 is 10. 4 plus 4 is 8. So that's 18 altogether, plus x will give me the perimeter of that figure. Then to find the area, I need to find the area of the rectangle, which is length times width, so that's 4x. And I need to add it to the area of the triangle. Now remember, when you find area of a triangle, you do your base times your height divided by 2. So I know that this triangle's base is actually this part right here. I know that because I see this little perpendicular line, which gives me the height. So I see that the base of the triangle is actually x. So I'm adding the area of the triangle. So I have x times the height, so 3x, all over 2. So what I have on this right side of my equation, right here, this is area of the composite figure. What I have on the left side would be my perimeter. Okay, so I've done the first part. I've written my equation. So remember, this side is the perimeter expression on this side. And then over here, this is the area. Found the area of the rectangle plus the area of the triangle. Now, some of you are still iffy on your fraction operations. So for this one, this particular one, since we're talking about measurement, I will accept decimals. Okay? So it asks you to solve for x. So in order to solve for x, when you have variables on both sides, the first thing you have to do is clean up your problem. Notice that I have some like terms over here. So I'm going to go ahead and change this into a decimal for you guys. So we have 18 plus x equals 4x plus 1.5x. That's what 3 over 2 is. It's 1.5. So now, hopefully, if you didn't see it before, you see my like terms right here. I have 4x's and 1.5x's. So I'm going to combine those since they're on the same side of the equal sign. So I know that I have 18 plus x equals 5.5x. The next step is to move all your variables to one side. So in order to move a positive x, notice right here I have positive x, I'm using inverse operations. So I'm going to subtract x from both sides. Those will cancel, and I bring down my 18. And then 5.5x's minus an x would give me 4.5x's. Now I'm left with just a one-step equation. So the opposite of multiplying by 4.5 would be to divide by 4.5. So when I do that, I know that 18 divided by 4.5 is equal to 4. So x equals 4. Now, as I'm doing this, if you notice up here in class, you solved, but you had to explain the process that you used to find the solution. So let's kind of talk about that. The first thing that we did was we wrote an expression for perimeter. So that was step 1. Then the next thing we did is we wrote an expression for area. Now, when we did that, we had to find area of the rectangle plus the area of a triangle. So that's where this part of my equation came from. I was able to set those equal to each other based on what they told me in that first bullet point. Then you're just explaining the process of solving an equation. So we're combining like terms, then we're using inverse operations to get our variable to one side, and then we used inverse operations to isolate that variable. So the opposite of multiplying was to divide. That's how we got this number. Then the last thing it asks you to do is to find the perimeter and area. Well, if we know x, I can just sub it back in and then solve. So I'm going to put this 4 in right there for x. So if I know the perimeter is 18 plus x, well, 18 plus 4 is 22. So that means the perimeter of my figure is 22 feet. Okay? Then, to find the area, I just sub it into the other side of the equation, so right here. So I know to find area, I'm going to do 4 times x. So 4 times 4 is 16, plus 3 times x, so 3 times 4 is 12, divided by 2 is 6. So 16 plus 6 gives me 22, which you should have been expecting because it told us 22 square feet, by the way. But it told us up here that the unusual property was that the perimeter and the area were equal. So the fact that these came up equal tells me that I did my problem correctly. Okay? If this doesn't make sense to you, it's a lot. It's taking what you know about equations and taking what you know about geometry and putting it together. So if you're struggling, please come in for tutoring. Now on the next slide, I'm going to do 2 more problems, just reviewing solving equations with variables on both sides in case you have any questions about that, because we're going to spend another day on it, but I want to make sure you understand. So what I've done here is I've put the steps for solving these, and I'm going to go through them as I solve. So step 1 is to use inverse operations to move all your variables to one side and constants to the other. Remember, constants are numbers without variables. Now in this first problem, we don't have to worry about that because I just need to get my variables over to one side. So I'm still using inverse operations. So the opposite of subtracting is to add. So I'm going to add 4x to both sides. So when I do that, negative 4x and positive 4x will cancel. You bring down your 10, and then negative 9x plus 4x is negative 5x. Now it's just a one-step equation like we worked on last week. So the opposite of multiplying by negative 5 is to divide both sides by negative 5. And when I do that, the negative 5 divided by negative 5 makes 1x, and 10 divided by negative 5 makes negative 2. Now, just like with the problems we worked on last week, you could always plug that in and check it. You could plug in your negative 2 into your equation and see 10 minus 4 times negative 2. Well, negative 4 times negative 2 makes 8. 10 plus 8 is going to be 18. And then if I plugged it in on the other side, negative 9 times negative 2 is also 18. So I know that this equation is balanced. Okay? Now this problem is fairly basic. It's just got the one step where I had to move the variables. If you look at this second one, this is a little more messy. So let's go ahead and look at it as well. So the first step here, I have distribution occurring on both sides. I know that because I see parentheses. So I'm going to distribute my 3 on the left, and I'm going to get 9x minus 12 equals, then I'm going to distribute my 1/4. Now remember, when you're distributing a fraction to a whole number, all you do is multiply the numerator and divide by the denominator. So 1/4 times 32x is really just 32x divided by 4. So 32 divided by 4 is 8x. And then 1/4 times 56 really just means 56 divided by 4, which is 14. So just in one step, I've cleaned up this problem quite a bit. Now I'm going to go ahead and move my variables to the left and my constants to the right. I generally move my smaller variable, but it doesn't matter. I could go either way. So I'm going to move 8x to the other side, so the opposite of positive 8x is negative 8x. So I'm going to subtract that from both sides. When I do that, those are going to cancel, and 9x minus 8x is 1x. Then I'm going to deal with my constants. Well, if I moved my x's to the left, that means I need to move that negative 12 to the right. So the opposite of minus 12 is plus 12. So I'm going to add 12 to both sides. When I do that, my positive and negative 12 cancel, and 14 plus 12 is 26. So that means that x must be equal to 26. Okay, so we've been solving equations now for about a week and a half. If you are still struggling with this, because as you can see it's getting a little more complex each day, I encourage you to come in for tutoring as soon as possible. That way you don't fall behind. Pretty much everything we do in class is going to start with manipulating some sort of equation. I hope you guys have a fantastic evening, and I'll see you tomorrow.